Hello, my name is Yarinet Rivera, and for my linear algebra video project problem, I will be solving this. Let p of x equal x plus x to the second power plus x to the third power plus all the way to plus x to the ninth power. We're going to compute p of the matrix with entries -2, 0, 0, and 3. Well, to start off, having the matrix inside these parentheses lets us know that x equals -2, 0, 0, 3 of this matrix using this equation. Therefore, we know that if px equals x plus x to the second power plus x to the third power plus ... plus x to the ninth power, then we know that p of the matrix with entries -2, 0, 0, and 3 will equal the matrix raised to the first power plus the same matrix raised to the second power plus the same matrix raised to the third power plus ... all the way to plus the same matrix raised to the ninth power. Now, when a matrix is raised to an exponent, that means that all of its entries will be raised to the same exponent, each one individually. Therefore, this will then equal the first matrix is raised to the first power, so it remains the same. This new matrix, since 0 and 0 raised to the second power equals 0, I will leave them just like that. -2 will be raised to the second power, and 3 will be raised to the second power. In the next matrix, -2 will be raised to the third power, 0 and 0 to the third power would equal 0, so these stay the same, and 3 to the third power. In the last matrix, -2 will be raised to the ninth power, 0 and 0 to the ninth power remain equal to 0, and 3 will be raised to the ninth power. Now, when you add a matrix or several matrices, you will be adding the entries that are in the same position into the new matrix. Therefore, the first entry of the new matrix will include -2 plus -2 to the second power plus -2 to the third power plus ... plus ... to the ninth power. The second entry in the first row of the new matrix will contain 0 plus 0 plus 0 plus ... all the way to plus 0, which equals 0. The first entry in the second row of the new matrix will be 0 plus 0 plus 0 plus ... plus all the way to 0, which equals 0. And the second entry of the second row of the new matrix will equal 3 plus 3 to the second power plus 3 to the third power plus ... plus 3 to the ninth power. It will look like this. As you can see, the first entry is now composed of -2 plus -2 to the second power plus -2 to the third power plus ... plus -2 to the ninth power. The second entry of the first row is 0 because that is the sum of all zeros added. This is also the sum of all zeros added in the first entry of the second row. And the second entry of the second row is 3 plus 3 to the second power plus 3 to the third power plus ... plus 3 to the ninth power. Now, to solve these, we could just add them all up, including -2 to the fourth power, -2 to the fifth power, but what we are going to use is a finite sum. A finite sum is very helpful when we have these long sequences. Here is the finite sum we are going to use. The starting number of k is 1, and the ending number is n. In this case, we're using a to the k because this is what's going on in our entries. These two entries are the ones we will be solving for because they're the ones with the unknown sum. So, an entry with a starting number of k equals 1 and an ending number of n equals a plus a to the second plus a to the third plus ... all the way to plus a to the n. Therefore, in our case, our starting number is still 1, and our ending number is k would be 9. Therefore, at the top we put n is 9 and k is 1. It would look like this. As you can see here, our new number at the top is 9 and our bottom number is 1. We're solving for our first entry in the first row, negative 2 to the k, which equals what we currently have, negative 2 plus negative 2 to the second power plus negative 2 to the third power plus ... plus negative 2 to the 9th power. According to my calculations, this equals negative 342. Now, the second entry of the second row also has the ending k number of 9 and the first number of 1. Our first exponent is 3 to the 1. It's invisible, so it's just 3 plus 3 to the second power plus 3 to the third power plus ... all the way to plus 3 to the 9th power. This equals 29,523. Now that we have the sum of these sequences, we can input them into our solution. Therefore, P of our matrix negative 2, 0, 0, 3 equals this new matrix with the first entry negative 342, 0, 0, and 29,523. This has been my video project problem by Yarinet Rivera. Thank you for watching.